Okay, we have practice problems for section 2.1, starting with problem 5. We want to identify which values come from the sample and are a sample mean, and which value represent what is sort of claimed to be the current population mean. So first part A, American households spent an average of about $52 in 2007 on Halloween merchandise. To see if this number has changed, researchers conducted a new survey in 2008. And the survey included 1,500 households, found average Halloween spending was $58 per household. So we are going into this research with sort of a fixed value that is what is claimed to be true about the population. That is the $52. So the population mean is $52. And then we look to see, well, what value, what average, what mean is coming from the sample that's taken, and that is the $58. The other thing that I want to add at this point is some notation. We're not quite using this yet, but sample mean, we use the notation of X with a bar. That just stands for a mean that comes from a sample. And when we talk about population mean, we use the Greek letter mu. It's kind of like a U with a long tail in the front. And the way we say that is mu. Kind of like we're a cat and we're mewing. So just mu. Okay, part B. Average GPA of students in 2001 at a private university was 3.37. A survey on a sample of 203 students from this university yielded an average GPA of 5.39 a decade later. Okay, again, we want to separate out what comes from the sample, what is claimed to be the population prior to that. All right, so the sample mean GPA is that 3.59 coming from that sample of 203 students. And again, we can use X bar to stand for that. And then the population mean, the one that was assumed to be true before we took that sample, was 3.37. And again, we can use mu to stand for that. Exercise 10 has us looking at some histograms and then matching them with the box plot and describing the distribution of the data that is represented in the histograms and the box plot. So we're going to start with histogram A. And ways to think about how you describe it is how many modes does it have and what is the shape of the histogram. All right, so it is unimodal. All right, there's only one peak. All right, it goes up and then it goes back down. And it is also symmetric. It's not, doesn't have a long tail on either side. The tail is about even on either side. And then if we look at the box plots, a lot of the data is sort of grouped. I'm going to kind of grouped in the center. All right, the bars, the histogram bars are taller in the center towards the mean. Okay, so that means that in the middle quartiles, there are more values in those quartiles. Okay, so the values for those quartiles is going to have a smaller range. So those quartiles are kind of condensed. Okay, so if we look at our box plots. So number one, we can get rid of that because it's not symmetric, right? It's got a lot of values above the middle and below, and not very many below. All right, that's not symmetric. 2 and 3 are both symmetric. All right, but number 2, here we have not very large range from the median to the third and the first quartile. So that means that there's a lot of values packed in there. And so that is also going along with having these high histogram bars towards the center. All right, so number 2 is the box plot that goes along with histogram A. Now let's look at histogram B. This is what we would call uniform, right? There is one mode here, but generally they're all about the same height. So what we want to describe that as uniform, not really a mode. And it's, basically symmetric, but uniform really captures that as well. Now, if we look at the box plot that's uniform, again, we can count out number 1 because that's got a lot of values above and very few below, so that doesn't match that uniform where it's spread out evenly. We can get rid of 2 because we already used that one for part A, which leads number 3. And we can see that it is uniform, like the distance between the minimum and the first quartile and the median and the third quartile, and the third quartile and the max are all about the same. So that means that the data values are spread out evenly from the minimum to the max, which matches up with the uniform distribution. Histogram C. All right, it is unimodal, but it's not symmetric, right? We have a longer tail on the right, which means that it is skewed, and because the tail is longer on the right, that is the direction of the skew, so it's skewed right. And we can, oops, that's not what I want. We can discount number 2 and 3. We already used those, and so we see that it matches up with the box plot number 1. Let me get that written right, number 1. And we can see that matches up with this tail, matches up with all of these values that are above, that are much larger than the other values. And then not very many values are on the right, so that matches up with not very many values going from the first quartile to the minimum value.